Alright, we have our gearbox plate in the back in the mill now, and what I've done, I've gone ahead and found the center, and I went over there on the bench. I'll put these dimensions on the drawings when I get done, but this is our center mark right here. That's the center of the circle. I also drew on the circle the size of the hole here, so we get just a rough idea of where we want to put our holes to mount this piece. This piece is going to sit rigid over this. Be sure that's all still in frame. I don't know what this height will be yet. That'll be probably the last thing we determine. But it's very important that these holes mount up. Now, 3 would have been sufficient, but not being able to go that full circle back there, I wasn't able to get 3 proportionally and not run into this oil fill plug. If I got off the side of that, one would hit over here and the other one off in this part that don't exist over there. So I'm going to use 4 bolts just to keep it looking symmetrical, and I don't have anything that's exactly that length there. These 2 flat edges are not the same. The motor housing goes in just a little bit where the gearbox plate will sit, a little bit more so than even after we cut the fins out. So I'm just going to set something that's close in there, a couple of parallels. Get that bumped up to it so that it's so both surfaces are flat. We'll get this down close now. Alright, that's good on my x-axis. On the y though, oh, shoot, I'm not sure I can get it any closer than that. Yeah, it needs to come out just good on the X. Now, what that's done, that has assured me that the center of this, and I've just got some down pressure on it now, that the center of this is lined up with the center of the hole in the gearbox plate. Now, I'm not going to bore you with setup, but what I'm going to do is I'm going to go off camera for just a minute. I'm going to put some toe clamps on each side right here. You'll see the result when I come back, because I do not want this to move. Then I'm going to put a couple holes back here, a couple holes up here. These will be holes that will an 832 screw will go through to mount these posts. Again, these 2 pieces will be rigid to each other, but we do not know the height yet. Alright, I've toe clamped it down. I'm satisfied that everything is good and secure. Again, we're going to put a couple holes here, a couple holes back here. These will be 832s. So I'm going to start out. This measurement is 1.775. Now, some of this may vary unless you've got this exact same mill. It's obviously going to vary, but what I'm intending to do is put it halfway in between the circle, the hole that's in the gearbox base plate, and this outer dimension of this, 1.775. And from center, go over 0.60. 60 thousandths. I believe that should have been 0.6, not 0.06. 600 thousandths. I want to go through both pieces, of course. using 11/64 bit, 11/64 bit for the number 8 screw. Now I'm going to change tools in between each hole. This actually will be countersunk. This is the top of this piece, so we're going to countersink these. I'll be using socket head cap screws in these. Get our countersink in. And that turned up just a little bit of a burr there, so let me clean that burr up first and then I'll set the DRO. Alright, setting the Z-Axis Dro, and we'll want depth of at least 160 thousandths. We'll go 175 thousandths deep. This bottom plate, the gearbox plate, will be counterbored from the bottom side. Now we want to move over, since this was 600 thousandths, we want to go 1.2. Zero out my DRO, 175 thousandths. Now I'll continue this process for the back two holes as well. As I said, I plan on making a set of drawings for this, just for my own benefit if nothing else. But in case I forget them, from center again, let me go back to 0 on both axes. Alright, there's 0 on the Y. There's 0 on the X. We want to go on the Y 800,000. And again, there's nothing magical about these numbers. It's just the about halfway in between, and so that it landed on a good spot between both of the two pieces. Then 1.650 on the x-axis. And I'll repeat the process for the two holes here. Alright, I'm going to leave the counter bore in there for a second. Alright, I'm going to break this down real quickly, and then we're going to counter bore while we have that, while we have the counter bore in the mill. We'll counter bore the bottom piece. Alright, so those holes, these holes should line up perfectly with those. So now what we need to do is counter bore from the bottom side. And for the counter bore, just there's no need to indicate these in. It'd be just a matter of placing the counter bore, unlocking the table and finding that location. Of course, it's fine to reset my 0 now. Alright, reset to 0 on the Z and go down 175. It should be approximately 1.2. Should be dead on 1.2 in between them. And here's our plate, our gearbox plate, counterboard from the bottom side, this counterboard from the top side. All the holes should line up. Now what we want to start next working on is the hole for the impact wrench, the socket to pass through when it's reaching the drawbar, and also the mounting holes for our pistons, not our pistons, but our slide rods that will be up on top. So I'll get set up for that and be back. All right, we have our fixture plate. I'm really not sure what the terminology is for all this stuff, if there is terminology. But anyhow, this is our top plate that, again, will be rigid to this. We did our counter bore holes, indicated them or laid them out together. These two will be rigid to each other. Now what we need in this, I've got it setting in the vise now. I've got a V-block here setting across the parallel so it doesn't fall between the vise ways, tied up against the back jaw, and located the center point again. What we're going to do, see if that's in there where you can see it okay. This is our piece that's in the vise now. On this center line, we're going to come down 0.450 and we're going to put in a 1/4 inch hole. It'll be for a 1/4 inch socket head cap screw that will be counterbored from the bottom side. Do the same thing down here at 3.2 inches. We're going to reference everything here off of this flat edge right here and down the center line. What that will do, this is the piece shown down here that will, the impact wrench will mount in the big hole. We'll put a big hole in it, 1.162. We'll put a couple 5-inch holes, half inch holes, the same distance here, 0.450 from the end and 3.2 from the end. That's what this piece, remember, this is rigid to our gearbox plate. This piece is going to ride up and down to engage. It'll have about 1 inch of travel, if that much, to engage and disengage the socket on the drawbar. So this will be our floating piece right here. But we'll start out doing the holes in this. Again, I've got the, I'm going to lock down the X because that will keep us on the center line. And now we want to come back and off of this, off of that back jaw, we want to find that edge and set our 0. Not wanting to take that out. Alright, we'll put our edge finder in. And just snug it into chuck. Now that should be 1.4 inches. You know, there really isn't any chance, any need to indicate that back jaw. I've measured that and measured that, and I'm comfortable that that's a 1.4 inches. So if we set 0 out the DRO on the Y and come back 1.4, all right. Now, just for my own satisfaction, that point should be right on that edge, which it is. So we'll 0 out the Y-axis and 0 out the X-axis. So we want to come on Y, according to my drawing, 0.450. And these are probably the most crucial measurements of the whole thing, that we get this, the holes in it, lined up with our floating piece here that will float up and down, because there's going to be not 100% sure yet whether I'm going to use stainless steel or brass. I think I've got some 3/4 brass that'll work real good right there. So for this, I think I will go ahead and use a starter bit in there. And gonna have to go up. And remember, if this gets counterbored, whether it get counterbored from the bottom side. Now we'll come back and pick up that center hole in a second. That center hole is what the socket will ride up and down through. So it needs about 1 inch to have plenty of clearance, but we'll get our next hole, which was 3.2 inches from that back side. See if that chuck's going to clear. Let me get a little longer center drill there, and I won't have to navigate so much with the head. It's wanting to kind of hide from me behind the V-block. And that looks like it's going to hit my parallel there. I think she's plenty tied in there. I want that parallel back under there before we start drilling that. Oh boy, I didn't want to move it. Since she's moved, take it out and get that burr off the bottom. Be right back when I got it set back up. Alright, Mr. Bozo never fails to show up, but I think we've recovered now. That's why I wanted to do everything off of this flat edge right here instead of trying to measure from one of the curved edges. With having that flat edge there, I'm comfortable. I'm back on my center line. Now we're going to drill out the 1 inch from the that, as I said earlier, the socket will slide through. I think I got enough coil here. And I'm going to step this with the 1/4 and then the 5/8, and then we'll go to the 1 inch. Alright, real slow and easy. Matter of fact, let me slow down. Alright, I believe we're well done with this mounting plate. After the bozo a while ago where it had to take it out to get the parallel back under, I carried it over to the mini mill and put the counterbore in there and went ahead and counterbored the bottom side. So I think we're done with this piece now. I'll get set up for the floating block and be right back.